Hi, great morning, one and all. I'm Kavya. I'm from Andhra Pradesh, Tamil. I completed my post-graduation in physics in specialization. My specialization was condensed matter physics. After completion of my post-graduation, I have worked as a lecturer for BSc students. And then I switched to Bangalore. There I worked as a lecturer for intermediate students like a JL. But due to maternal gap, I have stopped working there and kept preparing for physics jobs and other things. And so that now my daughters are able to go to school and elders are okay to care my daughters. I'm able to restart my career. And also, it's about myself. And coming to the today's part, the topic I'm going to present via PPT, I'm going to share here. This is about an interesting topic to the students, which is magnetic levitation. Let's go through what is magnetic levitation and why it is so interesting and where we can notice in real life. Everything we're going to notice and talk in this topic. Okay. Um. Yeah. Our learning points are going to be like this. Let me ask you something. Have you ever seen that floating kind of trains where the trains move without touching the rail? That means they don't touch the tracks or what we say that rail. That we say as maglev trains. They usually be in Japan and China. In advanced countries, they are already implementing this technology and they float above the rail using magnetism. And do you ever wonder how do that trains move and where in other domains or where we can notice this kind of a phenomenon, this levitation, uh, and what is the physics behind this? What are all the laws implementing here? We can notice, as shown in this diagram, the magnetic levitation, where this is not touching the rail and moving very freely. Okay, coming to the next slide, we can notice from one small experiment before going to the physics. We can do it, this phenomenon, even at our home if we have these simple apparatus of strong neodymium magnet and one aluminum or a copper pipe, which is a kind of ring, non-magnetic metal, and one support stand. From that, if we pass through, if we pass through the magnet through the copper pipe or aluminum pipe, what usually happens and what we notice and what do we can name that phenomena, we can notice from this experiment, and then we can study what is actually happening there and what are all the laws behind that phenomena and the physics, the beautiful physics we can get to study there. When that magnet is passing through aluminum foil, sorry, it's not a foil, aluminum pipe. It don't touch the pipe or it don't fall down immediately as per the earth gravitation, but it starts floating there. Uh, can you anyone imagine why it is happening and why it is floating or levitating there? Doesn't it looks like a magical thing? And let us get the science behind it. Normally, when we drop any object, gravity pulls it down and falls quickly. But in this case, when the magnet enters the pipe, it creates eddy current inside the pipe. The eddy current produces their own magnetic field. Eddy currents means mm, when the magnetic fields are varying, uh, the current produces. This is said to be eddy current. In the metal, it is happening against the magnet. Because of this, the magnet slows down and it looks like the magnet is levitating and floating there. It appears to float there. And coming to next slide, what is the physics actually behind this? We can formulate for this phenomenon as there is some induced EMF is developing, like EMF is a negative sign of that flux developing as per the time varies. So that negative sign of the variation of the flux, negative, I mean, minus d phi by dt, which is EMF. This means the faster the flux changes, the stronger the induced current will be. And also, the opposing magnetic forces is proportional to the magnetic velocity. So, the magnet moves faster, the resistance, the forces becomes stronger. This is the Faraday's law, we can say, and the energy is not lost. It is converted into the heat in the pipe, which is the system obeys the conservation of the energy. And Lynch law we can notice here, that is the induced current always opposes the change that produces in it. And here the current magnetic field opposes the magnetic fall, creating the levitation breaking. And suppose if we come to see these in real life applications, and also the formulative things also we can notice from that. Eddy currents causes the magnetic damping. It's like, for the eddy current, we can state one more example like electric heater. When the heater, by switching on to the electric field, and when do we put that water heater into the bucket, the water gets heated because of that eddy currents developing in it. When the metal without touching, it can produce the heat using the eddy current, and work done against this force is converting into the heat in the metal. This explains why high speed motion is equal to stronger the opposing the force. We can equate to this phenomena like force there is directly proportional to the negative of the velocity, where force is opposing and V is velocity. I mean, F is the force and V is the velocity. Okay. And coming to the real life applications, magnetic levitation trains, there we can notice the levitation, what is, and frictionless motion, as it is levitation motion. There is no any friction between the rail and the train, so that we can attain the maximum speed there. And roller coasters, magnetic braking and safe smooth happens there. And also induction cooktops. In induction cookware also eddy currents are producing, and metal detectors like brake systems in the industry. All these are all real life applications of magnetic levitation. And if we seek the conclusion for this topic, magnetic levitation is a beautiful mixture of physics along with the technology. This demo shows how Lenz's law is not just a theory, it has the real life use. Future of the transport and energy depends upon the heavily on the principles. And isn't it the amazing? So that already, as we noticed some formula for this, we can also solve mathematical problems using that formula in different scenarios, in different situations using that. As of now, we are going to end this topic afternoon. Yeah, thank you for this topic and opportunity.